Alright, so we were asked about this homework problem in class, and I said I would make a video to help you guys evaluate it. So what the homework problem wants you to do is that it wants you to estimate the area under this curve on this interval using this many rectangles, and it wants you to do it using the right hand, left hand, and the midpoint. The other part of this problem is that it doesn't want you to evaluate these by hand. It wants you to use technology. So the first thing we're going to do is I'm going to show you how to write each of these out. Then I'm going to show you how to plug them in to different sources of technology. So we're going to look at using the site Wolfram Alpha, then we're going to use ATI 84, and finally ATI 89. So to get us started, let's write down what R40 is. So I know that if I have R sub n, and I'm using summation notation, that's going to start when k equals 1 to n, change in x, f of a plus k times the change in x, aka delta x. So in our case, well, we have to figure out what delta x is first. So delta x is going to be b minus a, so remember those are my endpoints, divided by 40, which is my n, which is going to give me 1/10. I also know that my a is 0, which actually makes our life a little bit easier. So r sub 40 then is going to be the sum from k equals 1 to 40, and that's going to be 1/10 times f of, and well, a is 0, so we're just going to have 0 there, plus k times the change in x, which is 1/10. Okay, great. Now remember, this f of, and then all of this stuff in here, that means that we're going to plug all of that stuff in for this x here. So what that is going to be is that's going to be r 40 equals the sum from k equals 1 to 40. Oops, didn't mean to write equals there. 1/10 times, and if I'm plugging this into the square root, I can either write the square root, or something I like to do a little bit better, it doesn't matter, is you can write this as k times 1/10 to the 1/2 power. By the way, either way works, it doesn't really matter. Okay, so that's going to give us R40. Let's see what R40 would do. So let's do that in a different color. Let's do that in blue. So remember that the formula for Ln is going to be the sum from k equals 1 to n delta x times f of a plus, now instead of starting at k, remember we're going to start at k minus 1 times delta x. So our change in x hasn't changed, so that's still going to be 1/10, and our a hasn't changed either. Our a is still going to be 0. So L sub n then is going to be the sum from k equals 1 to 40. Sorry, I should have changed this. That should be 40. That's going to be, well, our delta x is still 1/10 times f of, our a is still 0, plus k minus 1 times delta x, which is 1/10. Now again, f of all of this stuff, that's going to get plugged in for my x right here. It's going to get plugged into there. So this is going to be L sub 40 equals the summation from k equals 1 to 40, 1/10, and if I plug that in, remember I can write it as k times 1 over 10 to the 1/2, or you can write it as the square root of, and that's going to be k minus 1 times 1/10. Great. So we have R40 and we have L40. All right, cool. Now, what we can do is we can go ahead and do M40. So I'm going to do M40. Going to erase these guys real quick. I'll just erase R. So we're going to do M40. Remember that M sub n, that is going to be, whoops, I wrote 4 instead of n. That is going to be the sum from k equals 1 to n delta x times f of, and we're still going to start at a, plus, but remember we're taking the middle, so that means that we're going to go halfway in between our delta x's. So this is going to be a formula. So m sub 40 will be the sum of k equals 1 to 40, and that's going to be 1/10 f of 0 plus k minus 1/2 times 1/10, which is going to be, oops, m sub 40 equals the sum from k equals 1 to 40 of 1/10 times the square root of k minus 1/2 times 1/10. And all of that is underneath the square root. Great, so now that we have formulas for R40, L40, and M40, let's try plugging those into our calculators. So let's just start with plugging in R sub 40, which we said was the sum from k equals 1 to 40, 1/10 times, and remember this was k times 1/10 raised to 1/2. So if we're going to plug this into, say, Wolfram Alpha, well, here's what we need to do. We need to tell Wolfram Alpha that we're taking the sum. So we're going to write sum. We're going to plug this in. And there's a couple of other pieces of information that Wolfram Alpha is going to need. It's going to need what's our variable, where are we starting, and where are we ending. Okay, so our variable is k. We're going to start the summation from 1. We're going to go to 40. So let's go ahead and check that out. So you're going to open your computer in Google or whatever you want. I'll type in Wolfram Alpha. Go to the very first one. So you can also type in wolframalpha.com if you'd like to. Whatever, either way works. Now here, where we're going to enter what we want to know about, well, we want to take the sum of, and now we want to type in this formula right here. So we are going to type in 1/10 times k times 1/10 to the 1/2 power. And now that we have our function in there, we want to tell it that we're looking at the variable k. We want to sum up from 1 to 40. Once you have that typed in, we're going to hit enter. And here's the nice thing about Wolfram Alpha, is that it'll write it out how it thinks you wanted it written out. So our answer is going to be 5.4269, etc., etc., etc. Awesome. So that's how you do that using Wolfram Alpha. Remember, you want to type in the function, comma, what's our variable, comma, where are we starting from, comma, where are we ending. All right, great. Let's do the same thing, only this time, let's use the TI-84. So we'll start with TI-84. So here, you want to turn it on. What we want to do is we want to do some math. So you're going to go ahead and click this math button right here. Now, after you click the math button, what we want to do is that we want to get to summation. So you can get here either by pressing 0 or scrolling all the way down. So we want to do summation. And it's going to prompt you. So what's your variable? So just for ease, because I don't want to keep hitting alpha and then the K button and whatever, which you can totally do. I'm just going to let my variable be x. My variable is going to start at 1, and it's going to go to 40. And then in here, I need to type all of this business in. So I need 1 divided by 10 times. Now remember, this is the same thing as writing the square root. So if you'd like to, you can put the square root button. And we're going to have x times 1/10. Wait, no, I wanted that under there. Shoot. Okay, I can fix it. There we go. 1/10. Delete that guy. Yep, we're all good. And then hit enter. And we're going to get 5.4269, which is the same thing that we got when we used Wolfram Alpha. Finally, if you want to do this using the DI-89, it's going to be ever so slightly different. So you're going to start the same way by turning your calculator on. Okay. You're going to start off at the home screen that looks like this. What you're going to do is that we want to get to this F3 folder, which is calc. So we're going to hit F3. We want to do summations, so we're going to scroll down to sum. Now what we're going to do is that we're going to type in this expression here. So we have 1/10 times, again, you can use K, I like to use X just because the button's right there, times the square root of X times 1/10. And just like on Wolfram Alpha, after we input this expression, we also want to tell it, comma, our variable's X, comma, where we're starting from, comma, where we're ending, which is at 40. Hit enter. Wait forever. Wait forever.